And we're back for another episode at the HVAC Grapevine, and we are live at the NCI Summit. And this potentially is our last show on the schedule. May not be, we might squeeze it in somewhere and show up somewhere, like a ghost. So we'll see how that goes. So this episode is one that we've tried to get on the books for a while, but to get a little piece of Steve Rogers' time, man, it's a big ask.
He's a busy guy.
It's like trying to get Brian Orr on the show. That's never going to happen, but we keep throwing those nuggets out there. Like, come on, Brian.
It's just because your show is during Sunday evening dinner with my kids.
Yeah. Well, somebody has their priorities right.
Yeah. That's right. That's right.
So
somebody's got Friday nights locked down. So
yeah. Oh, yeah. We should
introductions.
Yeah, for sure. Mr. Adam Muffich.
How you doing?
So if for anybody watching our show, I'm sure they're already watching your show, but maybe one person who's not, you're not watching the HVAC overtime show, you should be.
Yeah. Friday nights.
Yep, Friday
what time
nights.
Again?
8 p.m. Central.
Yeah.
9 p.m. Eastern or Floridian time.
Oh, okay. So 9 p.m. Yeah, I always say Louisiana time. That's where you're on. Okay.
That's right. So this episode is about blower doors, and we're gonna get pretty nerdy. We're gonna quickly cover basic blower door knowledge, like why do you need a blower door, but then we're gonna deep dive. We're gonna go into different test standards and methods and stuff like that. So we're gonna jump right into it. We've got about maybe a little less than an hour to take over this booth. So Steve, we're gonna rocket fire. You ready?
Yep.
All right. Blower door. Why do I need it? What does it measure? Give us the rundown. Why do people need a blower door in their life?
I'm going to give you the punchline from Chris Hughes. And here's the punchline. We're going to start with the punchline and work backwards. Punchline is, unfortunately, that's not the kind of house you bought.
Oh, I love that line.
Yeah. You want to tell us the backstory on that one, Chris?
It's been a while. And here's my issue with telling stories. I'll tell a story and then I forget it. And I tell another story and I have 20 years of stories, right? Yeah. And they just come and go.
Well, I could tell you the story if you forgot exactly how it went, because this one's stuck in my head a lot.
Okay. I probably told you like right when I came on board and we had this.
No, this is more recent than that.
Really? Okay. Yeah. No, yeah. Well, I'd love to hear it from your point.
This is why Chris started the show, so we could document the little stories. Yeah. He doesn't have to remember them.
Yeah.
So Chris told me about having conversations with homeowners and talk about their expectations for their new HVAC system. And they'd explain what they wanted. And Chris would say, well, okay, so you're telling me that what you really want out of the system, you want perfection. And the customer would go, yeah, that's what I want. I want perfection. And Chris's response was, yeah, unfortunately, you didn't buy that kind of house.
Dude, now you remember it?
Yeah, I remember the lady I told this to. Yeah. And I did like a quick investigation on her house, blower door and all that. And she's like, I want the inverter. And she had a little bit high humidity, right? Like, it'd flow to be in the 60 something percentile range, stuff like that. And she's like, yeah, I want this. I want that. I said, yeah. It's like, well, you didn't buy that kind of house. I'm like, I mean, you could upgrade, shell improvements and all that. We can make it happen. I'm like, but this box ain't going to do that for you.
Oh,
that's not how this works. And so I had to give her the whole building science spiel.
Right.
And, but it all worked out, Yeah.
I
mean, we gave her a nice install, a good system.
And she was able to ratchet back her expectations and realize it wasn't your fault.
Yeah. I mean, here's the deal. Shell upgrades aren't for everybody. Yeah. This homeowner realized she's not growing mold. She's got a little bit high humidity sometimes of the year.
Right.
This isn't a problematic house.
Yeah.
This is just
a comfort.
It's a comfort issue. And it's like, how annoyed are you? Are you annoyed to start bringing in a home performance individual, tighten up your house? And her answer was no. I'm like, well then, okay, just understand it's not me that's the problem.
Okay.
It's your house.
Yeah. Right.
So you're saying that
that's why you need a blower door.
You need a blower door because you don't know.
Well,
'cause
that's
you don't
how I
know.
was able to tell her. Like, I told her very simply, I can't control your house.
Mm.
I can control the temperature. I can't control the humidity.
Right.
You didn't buy that kind of house.
Yeah.
You have to build that house, and you didn't build it that way.
Yeah.
So, yeah. So that was that. That
I
is
like
the
that
tool I
story.
needed to basically hammer down and give that explanation.
Yeah.
Okay. So, well, that was fun.
Yeah, that was
Yeah.
cool.
All right.
So to me,
Show over.
Yeah, done. All right, next episode.
Oh man, dude, I think that was a milestone for me. I've always wanted the overtime bell to just be played on the Grapevine
Dude,
show.
we
And
made
like,
it. I'm done.
yeah, we made it. Like, we just teared up a level, you know. So, Steve,
Don't quit on me again.
I bet you most people watching this show have probably ran a blower door. I know what a blower door is. They're like, hey, don't hit me with the basics. Go deep. I mean, we got
Yep.
Steve Rogers time. We need to go deep.
Yep.
And so, Steve, let's get into the test standards,
Yep.
right? Like, let's talk about, and I specifically want to get into the shell area one at
Yep.
some point in this.
Yeah.
But let's start with straight CFM 50 and then work our way through.
Sounds good to me.
Okay.
So when we talk about standards, the first thing to understand is that all the standards have some way of normalizing leakage, because otherwise, how do you compare a small house to a big house? Or on commercial buildings, there's even more difference between a small commercial building and a big commercial building. So they all have some way to normalize the amount of leakage. And so the way they normalize it is always by using a ratio or a fraction. So let's talk about what's the numerator and what's the denominator. And, you know, for those of you that don't love fractions, the numerator is the number on top, the denominator is the number on the bottom. And in all cases, the numerator is either your CFM 50 or it's your CFM at 75, right? But what changes from one standard to the next standard to the next standard is what's the denominator? What are we using to normalize so we can compare big houses to small houses or big buildings to small buildings? And in residential, most states have adopted the energy code and it uses ACH 50. Well, ACH 50, it's a single number, but it's really a ratio. It's air changes per hour, which means I take my leakage and I divide that by the volume. So if I divide leakage volume by house volume, then I just get how many times the air changes in an hour. And so that's where your air changes per hour comes from. And 50 is just the pressure, 50 pascals that you measured at. So the volume of the house is a convenient way to do it. And it works pretty well for residential houses, but it has a problem.
Yeah.
And the problem that it has is if you make a house that's twice as big, but has the same amount of leakage for the volume, that's actually a leakier house in terms of how much leaks through the shell area.
Right, compared to a smaller house. Yeah.
Compared to a smaller house.
And for those that don't own blower doors, ACH 50 is not, when you take the blower door off, I'm not going to leak 7 air changes per hour. It's just at that 50 pascals.
Yeah, right.
Because that confused me when I started.
Oh,
I'm
yeah.
easily confused. now,
There's
Steve.
natural.
Oh, yes. Yeah. So that's another one for us to talk about.
I confused ACH 50 with natural. Yeah, I was
Yeah.
like, oh wow, this is really leaky.
Yeah.
Yeah.
So let me explain the difference between ACH 50. ACH 50 is air changes per hour at 50 pascals, but your house doesn't leak at 50 pascals all the time. It might leak once in a while
Well,
at 50 pascals on a super windy day.
some of these Louisiana homes with room pressurization might be leaking.
It might be leaking that much, right? But ACH natural, that is how many air changes per hour does your house leak under natural leakage conditions.
Okay, cool.
And usually that's defined like, maybe we're going to say, well, the typical leakage pressure is more like 4 pascals.
Okay.
And so you take, instead of 50 pascals, you follow that line down to 4 pascals and see how many CFM is that.
Okay.
And so typically your ACH natural, sometimes called an ACH 4, other standards say natural is 3.
Oh, okay.
You know,
That
so
depends on the area.
right. And sometimes by ACH natural, what people mean is, well, I'm going to tell you exactly what the wind speed is and exactly what the temperature difference is. And then we're going to calculate the leakage at that specific condition.
Right. Because if you live on the ocean, you get a 10 knots every day. You're going to have a different natural ACH.
I want to dive just a little bit longer into that conversation and say, Steve, we offer a multi-point test.
Yep.
So what that means is you're ramping the blower door up from, say, 10 pascals, 15 pascals, 25 pascals, all up to 50. And I think we even
60.
shoot after, 60 pascals.
Really?
And can you explain why are we doing the multi-point, or why would it be beneficial to do a multi-point instead of a single point capture at 50 pascals?
Yeah. The most important reason to do a multi-point is if you actually want to estimate the leakage under natural conditions. And the reason for that is because houses don't all have exactly the same slope of that line. We've talked about there's that straight line that you draw with pressure and leakage.
Right.
But that line can have a different slope depending on how the leaks are, whether they're mostly smaller leaks. You got a lot of small leaks, or you got a couple big ones. And that will change the slope of that line. And that slope of the line is also called the exponent. And the exponent is in the mathematical equation for how we line those up.
One
Cool.
thing that you kind of let me or taught me, I guess, when I was doing that, the passive house project.
Yep.
What the exponent is helps you define and figure out how large the leaks are.
Yeah.
Right.
Yeah. And the relationship is that if you look at flow, we've talked about laminar or turbulent before, but you've probably heard me say that laminar flow never happens in ducts.
Okay.
Right? It's true. It never happens in ducts, but it does happen in leaks because they can be very tiny, very narrow. And if you look at the relationship between pressure and airflow through a laminar leak, it's actually linear. It's 1-to-1. So you double the pressure, you double the leakage.
Oh, right. So you don't have turbulence and it changes the variable. Okay.
Yeah.
That makes sense.
If it's a turbulent leak, it follows Bernoulli's equation, and if you double the pressure, you actually quadruple the leakage.
Oh, wow.
So turbulent flow acts very differently than laminar flow is. And when we do a blower door test, what we find out is that so laminar flow is linear, means it would have an exponent of 1. If it's following the Bernoulli's equation, it would have an exponent of 0.5, or its square root. It's a square root and squared relationship. Blower doors typically fall in between. And what that tells us is that some of the leaks are laminar and some of the leaks are turbulent. And so if we get closer to 0.5, we know that more of the leaks are turbulent, which means those are bigger holes.
Dude, that is, you said you wanted to go deep?
Yeah, we just went deep.
Yeah, that's
You're there. You got your scuba.
Now imagine me going to work for a TEC and being there 3 weeks, and I just got that conversation, and I was like, I think I came to the wrong place. I think I don't know, like I don't know if I belong here.
So I have a question.
I don't know what I'm gonna do.
I know we started off talking about like codes and standards, right? ACH. Somebody asked me after the session that I just did a little while ago, why would I not, if we're looking at a retrofit situation and we're trying to tighten up a shell on an older house?
Yep.
Why don't we tend to care about ACH? Like, what's another way of looking at it besides ACH 50?
If I'm comparing the same house before and after, I don't care how big it is. I just want to get the leakage down, right? So I just start from whatever the CFM 50 is, and I'm trying to get to half that or a third of that, or whatever my target is for passive house.
Yeah.
And so, just looking at the CFM 50 is all you need if you're trying to look at one single house. But of course, they can't write the building code that way, because the building code has to apply to big houses and small houses.
Yeah.
Right. And the reason that ACH falls apart when you start looking at really big and really small houses is because of something called the cube squared law, or the square cube law.
We're getting deep again.
Square cube law.
Yep. Okay. So if you have any three-dimensional object, say it's a box or it's a sphere, right? If you double the size of it, so you can say you got a house that's really small house, 20 by 20 by 20, let's just call it a cube.
Yeah.
Right. And then you make it, if you double it, want that dimension to 40 by 40 by 40.
It's a tesseract.
Yep.
Wait, somebody talk to
He's
me
a
like I'm
Marvel
3 and tell me what a tesseract is, please.
No, dude, it's from the Marvel
He's
show.
a Marvel fan.
Oh,
You know,
okay.
the Tesseract.
Oh yeah,
You can still talk to me like I'm 3.
Sorry.
So if you double the house,
if you double the size of the house of one dimension of the house, right?
Right.
So you're making that one side from 20 feet long to 40 feet long, but you did that to all 3 sides and double it. What you find out is that the area becomes 4 times as big,
oh wow,
but the volume becomes 8 times as big.
8 times as big.
Yeah. So the volume grows much faster than the shell area does.
Right. So this is why I have a problem with ACH 50 for me
Yep.
trying to like mentally. I
Yeah.
mean, it's great for code, fine.
And well, and actually, the ResNet, I think, is adopting an adjustment for really big houses where there's like a little bit of a penalty.
Oh, really?
Because the easiest way to make a really tight air house is to make a giant one.
To make a what now?
Make a giant house.
Big mansions always pass.
Yeah, but
Yeah.
so
Right.
if you're working on a house or you're looking for leaks, CFM 50 is just raw data.
Now-
You got 100
Yeah.
CFM. I put a little foam in. Now I got 50.
I
There
want
you go.
to
Done.
just quickly do like a red team, blue team argument here. Steve, is
Are
there?
you on the blue team?
Yeah, I'm blue team in
All
here.
right.
I'm blue team. I've got blinders on, and I'm trying to. What I'm doing is trying to debate and say, what if I've got a lot more volume of air
Yep.
in the house? Okay, so I got the same amount of leakage. My ACH went down, and people are mad at me because I'm passing, but I really have a loose house. But I have all this volume of air that's hanging out.
Yep.
Right. So there's another level of thermal mass that's hanging out.
Yep.
Is there less risk for having an uncomfortable house because the humidity that maybe comes in through infiltration and now gets dissipated into this thermal mass of volume of air that I have hanging out? Am I at less risk from a comfort problem because I have so much area?
Yeah. So for example, you mean so much volume, or area?
Yeah, if I'm go from failing to passing because I built a bigger house.
Yep.
But I also have twice as much air in the house, which
Yeah.
means if I get infiltration at the same rate from the small house to the big
It's
house,
a big bucket.
I have a
You don't have
big
to worry
bucket
about
of
it.
air
Yeah.
that can make my introduced infiltration to be displaced to the drier air, and it has more area to go. So my RH may not go up as high as it would have been in a less volume house.
So that's a if we're talking about air quality concerns,
Yeah.
yes, a bigger house helps because if you have 2 occupants and they each shower every day, you don't put 4 times as much humidity into the air from your showers. The humidity that comes out of our mouths when we breathe or from cooking, if you put that all in a bigger space, then it's gonna not have as big an impact.
Right. So if we were podcasting right now in like a small 10 by 10 room, CO2 would go up like
Yep.
crazy.
Bingo. Perfect analogy of what I'm saying.
And now we're in a great foyer here at the
Gymnasium,
hotel.
yeah.
So
No problem.
here's what I'm saying from the blue team.
So build
I-
a big house.
If I could argue the positive of ACH 50,
Yep.
it's the house gets bigger, it's easier to pass, but there's more volume of air in the house. So there is a little bit of a kickback there that says, well, it's going to be probably potentially less
Yeah.
problematic on a humidity standpoint.
Yeah. If IAQ were the main concern, then that would be a great argument. But there's another concern, and for the most part, the air tightness requirements are built around energy code, right? And you don't want the
Gotcha.
energy code to encourage bigger houses.
Yeah. Right.
Because bigger houses always need more energy.
Yeah.
Right.
Yeah.
So what you're saying is the reason you're not a huge fan of, say, ACH 50, and I hate to say not a fan is not the right words. It's just, it is what it is.
Yeah.
You're saying it's an enthalpy problem.
Mhm.
It's like, meaning there's more heat content coming in the house. And this is a Louisiana problem, right?
Yeah.
There's hot, humid air comes in the house.
Yep.
The enthalpy of air goes up and you have to contend with that.
Yeah.
That's
Right.
an energy
So
problem.
why did we go to ACH 50? Or, when we started doing blower doors, like what did we start with?
I'm not sure the history of who was behind what. I
Yeah.
know lots of the super nerds, I think, Gary and Colin at TEC included, would really prefer if it was based on shell area,
Shell
not,
area.
not volume.
That's where I want to go.
Oh,
Yeah.
okay.
That's where we got to go next. This
Yeah.
gets fun.
Yeah, but you got to explain that to me though.
Yeah,
What that
okay.
means. All right.
So shell area is if you add up the area of the walls and the ceiling and the floor,
Okay.
and count all that square footage. And then you divide the leakage by that area, then you get so many cubic feet per square foot of area. And this is the way that commercial buildings are done.
Oh, okay.
So most commercial buildings are following any particular standard, but the one that's most common is the Army Corps of Engineers air tightness standard. And it requires 0.25 cubic feet per minute per square foot of shell area. So for every square foot of shell area in the building, you can leak a quarter of a CFM. And actually, because it's tall buildings, they do it at 75 pascals, not 50.
Oh, wow.
So it's 0.25 CFM 75
So
per square foot of shell area.
Steve, can you explain why the commercial building is tested at 75 and a house is tested at 50?
Yes, because they're taller.
Okay. All right. There's more to that.
Yeah. The reason that that's important is because if you're testing like an 8-story building, a lot of times the stack effect gets larger if the building gets taller. So if I have, a 3-story house that's 20 feet-ish tall,
Right.
and then I compare that to a commercial building that's 40 feet tall,
Oh, geez. Yeah.
you have twice the stack pressure. And so if you test the building at 50 pascals in a really tall building, you might not get all the leaks blowing in or all the leaks blowing out. So you have to get a pressure that's high enough to overcome the natural stack.
Oh,
So-
you got to compensate for that natural stack.
Is
That's
that why
crazy.
they have all the revolving doors in Chicago on the
Yes.
skyscrapers?
Yes. That's why revolving doors were invented. And I think they were invented in Chicago because Chicago is the place where you had tall buildings and cold weather, which means you had really big stack effects. And it would have been just howling cold air into the lobby.
So
Um,
it goes
once you got
from
a
the
hot-
lobby and it goes up.
yes.
Where you guys are from goes. Whoosh,
Yep.
and then Florida goes the other way.
Yep.
Reverse stack effect.
Yep.
That's crazy.
So there's got to be some complex systems going on in the skyscrapers to try to help with stack effect, not just the revolving doors, but you
Yep.
got to think that stack effect has got to be insane.
Yes.
Yeah, Steve, what would be the normal pressure in cold weather Chicago? What would you see for a stack effect pressure on, say, a high rise that's, I don't know,
On-
30 stories tall?
On a cold day.
Yeah, on a
I
cold day.
can't do the math in my
Yeah.
head, but it's probably 40 to 70 pascals.
No way.
Wow.
Yeah.
That's the
Dude.
pressure difference between the first floor and the top floor.
Dude,
40. I mean,
what the heck?
that's
That's why you got to test at 75.
That's just
Well,
for everybody out
there
there.
you
That's
go.
like 0.2 inches
75.
of, that's like supply plenum duct pressure.
yeah.
It's huge.
Yeah.
And if you've ever walked into a skyscraper in Chicago on a cold day and used the sliding doors, you can feel it. It's like a duct blowing on you, blowing cold air in. So they've got the sliding doors if you need to, push the cart into the building, and they got the revolving
Right,
doors. And
right,
that's
right.
what that's all about. Yeah. Because
Wow.
if they had doors on hinges, they would just blow open or blow closed.
Yeah. It's like doing a blower door. That's
So they
crazy.
have the sliding doors and revolving doors on skyscrapers.
All right, you all ready?
Dude,
We're going to take it to another level.
Uh-oh.
I can't go no deeper.
This is the brain meltdown episode. All right, fast and hard. Here we go. Multifamily guarded blower door testing.
Yep.
Right. We haven't talked a lot about that in public, really. Like on the HVAC side. The HVAC
Yep.
side, we're not talking about that a whole lot. I know
Yep.
on the other side of the company,
Yeah.
Jake McAlpine, Colin, they're running that
Yep.
out really hard. Me, not so much. Right. We've been focused on HVAC.
Yeah.
You've been more on my team, kind of
Yep.
in the company, working the HVAC circle hard.
Yeah.
But let's talk about multifamily guarded blower door testing.
Let's start
First,
off with-
explain what a guarded blower door test
Yeah.
is.
and then
Okay.
explain what multifamily is exactly.
because
I
in
work
Franco,
on-
he's got all kinds of kids and people living in his house.
Yeah, we're talking like, a bunch of different families in one
Yeah,
house.
multifamily doesn't mean 3 generations in one house, Michael.
Yeah. I live in the basement. Mom lives upstairs. Grandma lives in the,
We're talking about different apartment units in the same building.
Oh, okay. We call those condos in Florida.
So, in
And And just in case the camera's not on Steve, all those calculations, he does not have a pad in front of him. That's coming from the brain.
Oh, okay.
Multifamily.
So multifamily testing. So the first thing you have to decide if you're going to test an apartment building is, are we trying to find out if each unit is airtight from the other units and from the outside? Or do we care if the entire building is airtight to the outside? And so the types of tests that we would want to do is if we only care about energy and we don't care if somebody smells somebody else's dinner in the apartment complex, then we would only test the entire building shell. And the way that that's done, as long as you've got a common entrance and hallways on the inside, then you open all the interior doors to each apartment, and then you put your blower door or fan or fans at the main entrance, or maybe more than one entrance, depending on how big it is. And then you're able to pressurize the entire building to the same pressure. And that's not a guarded test. That's just a whole building envelope test. The other kind of test that's done is called a compartmentalization test. And that test is to find out how tight is apartment 2A, is it leaking to the other apartments? And that matters for things like cooking odors or smoking, or sound, or all those things, air leakage from apartment to adjacent apartment.
Super tough to do like a hotel room, because every wall except maybe one, that's really hard. Jeez.
Yeah. And so, Steve, let's go in the weeds here. How do you perform such a blower door test to make sure that let's say I want to test room 2A.
Yep.
And I want to know the leakage of 2A. How do I neutralize that?
That sounds impossible to me.
Well, so let's first of all, let's paint a little picture in our heads. We got 3 stories and we got 4 units on each floor. So we got 1 ABCD.
Yep.
2 ABCD. And 3rd floor ABCD.
Yep.
And we want to test 2B, right?
Okay.
2nd floor.
That's what I had in mind with the hotel. It's hard.
Right.
Or not to be.
Or not to be.
That's guarding is when you test not to be.
Go ahead. Sorry.
Okay.
I call that the ice cream sandwich. That's what I call it.
Right.
The one in the middle.
Okay. So what you got to think about is, if I only want to test the leakage of 2B, if I pressurize or depressurize 2B to 50 pascals, then what's going to happen in 2A? I'm sucking some of the air through apartment 2A into 2B and out the blower door if I'm depressurizing, right?
Yeah.
That means that apartment 2A, if apartment 2B is at 50, what if apartment 2A gets to 5 pascals? Well, now I only have 45 pascals across that wall.
Oh, okay.
So I didn't test it at 50 on all the walls.
Right.
I tested at 50 on the exterior walls, but not the ones that are adjacent to other units, because I don't know what pressure those got to. So what you have to do there is, now I got to open the windows in 2A and 2C.
Oh my God.
And really,
Dude, that's
even
genius.
1B and 3B,
Right.
above and below, to make sure that I got 50 pascals across all the walls of 2B.
Right.
Right. And that will then tell me how much 2B leaks total at 50 pascals.
Okay.
And, pardon my long-winded answer here, but we're building up to guarding.
Mm-hmm.
But the next thing I probably want to know is, if I got the total leakage of 2B by doing what I said, I like open up the apartments around it. Now I want to know, well, wait a minute. How much of that leakage from 2B is from the outside walls,
Right.
and how much is from the other units?
You have to
So-
subtract that?
Yeah. You subtract it, and you subtract it by doing a guarded test.
Dude, that's crazy.
And so what I need to do is, I'm going to pressurize apartment 2B to 50 pascals,
Okay.
but then I'm going to, I want to get 2A, 2C, 3B, and 1B. I want to get those 4 apartments up to 50 pascals also.
Oh, really? So
Yeah.
just to do 2B,
Yep.
you got to go all around.
Yeah.
Wow.
And if I have a common hallway and stairwell that connects them all, then I can pressurize the entire building to 50 pascals with one blower door, like in the main lobby.
Yep. Main lobby.
Right. And then I've got that at 50 pascals. And then I've got another blower door that's just measuring the air that goes from outside through apartment 2B and then into the main hallway. Let's say we're depressurizing here.
So you're pressurizing at the main entrance and depressurizing.
No, I'm depressurizing the main entrance.
Okay. So you're depressurizing both.
Yes.
Right. Yeah. Okay.
I'm depressurizing at the main entrance, and then I'm going to depressurize apartment 2B.
Yeah.
But as I depressurize it, I'm actually measuring the pressure between 2B and the hallway, which should be 0. Okay. So there's 0 pressure between the hallway and 2B.
So if you're setting up your fan, you're not actually setting it. If you're doing cruise, you're not cruising 50 on those other units.
Cruising 0.
Well, the fans that are pressurizing in the main lobby,
yeah,
those ones are cruising 50 with reference to outdoors.
Yeah.
Oh, okay.
But 2B is cruising 0 with reference to the hallway,
which is 50 with reference to outdoors.
Exactly.
Yeah.
Yep.
Yeah.
Okay. So when
he's a blower door guy, bro.
He's been teaching me. I'm just pretending like I know stuff.
Picking it up pretty fast.
It's like a duct leakage downside test.
Yes, it's like a duct leakage
what
outside.
it is. Yeah.
And
So I'm not doing hotels.
Yeah.
Skipping that.
And just to throw this out there, this sounds like somebody's running around like a chicken with their head cut off to pull this off, but it's not. It's like there's a thing that we have a program, right? That is a tech log 4. Okay. It's a computer program that you hook all the blowers door to your computer, and then you operate all the blower doors from your computer while they're data logging. So you don't have to run around to gauge here, gauge there. It's all just connected to the software program. So you just drive them, from your laptop on the job site.
And you're getting like a real-time graph of the building pressures.
Oh, cool.
And how much flow is happening on each fan. You got all these lines going on the graph up and down.
So I got one thing to add there. Steve, I want you to speak on this one. This is something I feel like
let me finish up my explanation first.
Got it.
Okay. So once we get apartment 2B cruising 0 with reference to the hallway, well, there's still airflow coming through apartment 2B, but we know that all the airflow that's getting sucked into 2B is coming from outside.
Right.
Because there's no pressure across the walls on the inside. And so that way we can then measure just the leakage to the outside from apartment 2B. And that's a guarded test. We are guarding the inside leakage by making sure all the apartments around it are at 50 pascals. And if everything's at 50 with reference to outside, that means there's 0 pressure across that wall. It means it's not leaking.
Wow.
So
it's like a game of tug of war with air.
Real quick, I want to, Chris explained this to me, like wrapping your mind around this for the first time. It's like,
it's a lot,
you know, but the first time you explained it to me, it made a lot of sense. It's like what you're doing is you're patching all the holes in between the spaces, interior walls with air
patches.
So
you're
there's
plugging the
blower door
holes
on
with air.
each one of those.
Yep.
Okay. So you got, all right. So yeah. See, I'm a residential guy, so I'm thinking one blower door. So I'm like, this is impossible.
Yeah, you would think conceptually, like I don't have an engineering background, but you think like if I got a hole in a pipe, there's going to be some level of flow. But this is just not true. Like you literally and our trainer's really cool about this is like you got the duct inside the shell and you're running 2 fans.
Yeah.
And what I've done during training the trainer is I get people to stick their hand in the tent, make a seal. And I say, put your hand over the hole of that duct. I was like, you feel any flow? And they're like, no. And I'm like, isn't that wild? I was like, we got 2 fans going at the same time. They're battling each other.
Wow.
It's like there's literally an air patch over the hole. And so they put their hand over there and they're like, no flow. I'm like, so you're neutralizing the pressure on both sides.
1, 2, 3, 4 blower doors and on the apartment to surround it from.
So you're just leading right in my next question, Michael, or my next explanation. So I talked about what if we have a common hallway that connects them all together?
Oh yeah.
And you can just put your blower doors in the lobby. But in Florida, you're more familiar with what we would call garden style apartments.
Yeah.
Where each apartment has a door to the outside and there's no common hallway. So if you're doing garden style apartments, yes, you actually have to have a blower door for each unit that you want to guard.
Right.
Because otherwise there's no way to get them all up to 50.
Yeah. Yeah. Because they have that just open, they got the whole open area in the front.
Yep.
So
do you give like package deals if somebody's going to buy like 6 blower doors at a time to do these kind of tests?
Yeah, we have volume discounts. Yeah.
Oh, nice.
Yeah.
So Steve, one thing that I've learned, and I'll just come out and say it, guys. Like, if you call me about big building blower door tests and expect me to be the guy with the answer, I'm not that guy at TC, right? There's other people for that. I'm just going to flat out lay it. I know some stuff and I'm trying to learn more. I'm just not all the way up to speed there yet.
But we still got a grapevine discount code, right?
That's right. So one thing I have learned from the team is what I thought was pretty interesting, and they put a lot of work in, is because what I want to hear from like the engineering side of the fan is we only need one baseline. Like, this is getting back to big building blower door test.
Yep.
Let's say you got 20 fans on a building.
Yep.
We need one baseline measurement. And that's literally due to the design of the fan is why we do that. Right.
Oh, I see. Yeah. So there's another manufacturer of blower doors.
That's okay.
Yeah. And their system you have to get a building pressure for each manometer that's connected to each fan. And that's because their flow measurement requires you to know the building pressure. Ours doesn't, which means that each fan requires only one channel. So it requires fewer manometers.
Oh, okay.
Yeah.
Gotcha.
And why is that, Steve? Like, what's the science behind the fan?
Because we engineered the flow sensor so that it's not affected by back pressure within the range, from 0 to 100 pascals. The back pressure won't affect the flow measurement reading. It's just the way we engineered the flow sensor.
Wow.
Gotcha.
So for open style, just to recap, like Florida condos, open style,
Garden
no
style.
hallway,
Yeah.
garden style.
Yep.
You would have to have possibly up to 4 blower doors running.
Yeah, sometimes even more.
Yeah, right. And one on the
Yeah.
unit you're trying to get to. So 5.
And the hardest thing is if I want to test the entire shell of a
Right.
garden style apartment,
Oh goodness. Yeah.
now I need not one blower door for the units around the one. I need one blower door for every apartment.
Every apartment.
Mm.
That sounds like a great
Yeah.
win for TEC. That's
Fortunately,
awesome.
I don't think that kind of test gets specified.
And
very
that's
often.
why I have so many humidity issues on those condos. My buddy just called me earlier. It was like, oh yeah, I don't want to get into it.
I think the bigger issue on that is there's just not enough load in these individual units, and we
Yeah.
got manufactured equipment that's
Yes.
really hard to find anything that's
And
under a
there's the
ton and a half
same-
unitary.
Yeah, and there's
Yeah.
a ton and a half on every unit, and it's
Yeah.
500 square foot. That's what we just went over.
Yeah, like what are you going to
In the
do
hotel
that
room.
And it has-
situation? I mean, there's
It
answers
has
to it.
one exterior wall.
Yes,
Yeah.
yes, one exterior
Load.
wall.
Facing
That's got-
north.
Yeah, facing
Dude.
north.
Dude, it's crazy. I got high humidity. Well, there's only so many dehumidifiers you can put in 500 square feet.
Yeah.
More blower door stuff. What do we got? What do we got? I'm so deep right now. My head's
I know. I'm trying to brainstorm now. What did we not cover?
Well, whatever I interrupted you from.
Well,
you were going somewhere.
my main thing was I was really interested in the baseline conversation just because I know
Oh.
we're wanting me to, for me in my career over with you, is to kind of get me into more big building blower
Yeah.
door training so
Yeah.
I can start to deliver more of that training at some point, maybe. I don't know.
Yeah.
But anyway, it's when you have the baseline and you only have to have one, then everything gets connected digitally, right?
Yeah.
Back to tech log.
Yeah.
So that's a nice win. It's
Right.
I guess what I'm trying to say is I think people are fearful in hooking up all these fans and making it run like it's super complicated.
Yeah.
But it can actually be done very simply, with connectivity and
Yeah.
seamlessly. It's not like it's a nightmare to make it happen.
right.
Well, on big buildings, you have to worry about things like bottlenecks more too. So let's say you got a fairly tall building and it's only got one stairwell. One of the pressure measurements you really want to make is what's the pressure difference between the ground floor lobby where my fans are and the top hallway?
Right.
Because if I can't get enough air through that stairwell to depressurize the top floor,
You're not actually at 50
I'm not at 50 on
Right.
the
or
top floor.
75 if it's a
It's
commercial
75.
building.
Yeah. So I got to measure the difference between the top floor and the bottom floor
Right.
and make sure that is at close to zero.
So what do you do if you're not? You got to knock out a window and pop a blower door in on the top?
Typically, a building that tall is going to have a roof access door. And
Oh.
so you typically have to put a fan up on the top floor as well.
Ooh.
So that, then you can get that.
This leads me into
Yeah.
a good question that I had, and I don't know the answer, but I kind of understand that there's a process. And this came from Colin. I picked this up from Colin somewhere.
Yeah.
When you do a big building blower door test, there's like a blueprint review.
Yeah.
Right. There's a site plan. So like when you go to residential, you go to do a blower door test, you're not doing a site review of the blueprints that,
Yeah.
So for big building blower door test, typically if it's these tests cost a lot of money.
And this is new
they're not
construction?
cheap. Yeah. This is like the high rises being built.
Not always new construction.
Okay.
Yeah.
So like, and I know Colin does this for us, I think, right, from
Yeah.
time to time. So
And
people will,
Jake's good at it too. Yeah.
they will get our team involved and say, hey, we're going to test this 40-story building, and we need some kind of idea how many fans we need to bring to the job.
Right.
And so they'll give them the blueprints to say Colin or Jake, and they will look over the drawings to see. I'm assuming they're looking for choke points to see how many fans would you have to put on the third
Like
floor, the
bottlenecks
eighth
and
floor. Yeah,
stuff.
they're looking
Yeah.
for
And most importantly, you really got to understand the mechanicals in a big building. So do you have, outdoor air dampers? Do we need to mask those off? Do
Right.
you have, ventilation shaft? What are we going to do?
You
with
really
those?
need control of the whole
Yeah.
place.
So
shut it down almost.
Yeah, so big building blower door, it's like literally you're working with us to build a test plan.
Yeah.
That way, when you go up there, it's not willy nilly because you want to go in and you want to get done and you want to get out.
Yeah,
essentially.
because you could
So-
take all day. You get in there, they got fresh air, and you don't know how to close it off. You could spend you
Yeah.
could waste a lot of time.
So there's a test plan
Yeah.
for mechanical shutdown review. What are we sealing? What are we not sealing?
Yeah.
Is there choke points? If so,
Yep.
where's the fans going to go? How are we going to connect that fan to this fan
Right.
digitally? How are we
Yep.
going to do
If
that?
it's a casino, you can't get into this area, right? They
Yeah.
got the money over
Is there
here.
something we got to guard off?
Right,
A guarded
right.
test on this
Yep.
test that we don't want to be testing with. I mean it.
Yeah,
And I'm assuming, Steve, we're really
that's interesting.
running off we're running right here we
Yeah.
go. So in a big building like that, I've been in plenty of buildings like this, but they always have like the garage door areas, where the trucks come in and at for dumpsters and all that
Right.
kind of stuff.
Yep.
I'm assuming that's considered kind of like not part of the envelope outside space. In Louisiana, we don't care if that's conditioned, right?
Yeah.
We don't have like this crazy cold and impact from that.
Yeah.
So, our firewall, I guess you'd say, would be after that space.
Yeah.
And so I guess when you're testing, does those doors typically just get left open so it's considered outside?
Yeah, that's a good
And, like,
question.
I-
It's like
I
a
don't
garage
know-
door.
I don't know enough about the building standards to say. I can tell you, we actually did our first blower door test of our brand new building. And we've got a situation where we got a new dock area that separates. There's a garage door into the dock area and then another garage door into the truck.
Right.
Right. And that has to have a sprinkler in it, which
Oh.
means in Minnesota, we have to heat it to keep the sprinkler from freezing.
Oh, geez. It's a
cold weather problems.
Yeah.
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 That's right. Yeah.
So,
It's part of the envelope.
Yep. Part of the envelope. Yep.
Man, that's
So
wild.
what did the blower door test come back at?
We were really surprised. I thought, the humidity is a little higher than I thought since we moved in. We've been in the new building for like a month. We've had some pretty humid days.
Right.
And I thought, wow, our humidity is, higher than it was in the other building. And I thought that's because it's a leaky building. We did the blower door test and we, of course, used the Army Corps of Engineers standard, and the leakage came out just under half of what the Army Corps of Engineers standard requires. So it turns out it was a really pretty tight
Oh,
building.
it was good. Okay.
Yeah, right.
Yeah.
And that's with, we've got dock doors, and we know that the gaskets on the garage doors for our loading docks are not well sealed, and
Yep.
got a dock leveler that doesn't seal and stuff like that. So even with those pretty big leaks,
Yeah.
it's a pretty tight building.
And you had to take that as part of the envelope, which is
Yep. Right.
So you had to leave. You got your dock area.
Yep.
You had to left.
We actually
Yeah,
did
leave
left
that
the
door.
dock area closed because that's how it's going to be most of the time.
Right. It's got to
Yeah,
be closed.
But then there's another drive up that only has one door to the outside.
Right.
Yeah.
And you had to leave that open.
Yep.
Well, that stinks. Yeah.
Well,
And
no,
you
it,
still
it was,
came in
it,
tight.
it was closed, but the gaskets around that garage door are pretty
Right.
leaky.
Yeah.
All right, I got a fun topic. I'm
What do you got?
gonna circle back almost like back to the beginning here. Maybe this will polish this off. So when we talk about infiltration and natural infiltration and where the leaks are, what we didn't really talk about is how impactful it is depending on where the leaks are.
Yeah.
Right. And I think we should talk about that.
Yep.
There's a
Yeah.
lot to be said for this. And what I'm kind of leaning into C-Stack.
Yep.
We don't have to explain C-Stack. That could be something someone could go look up and learn. But can you speak on how, like, if you have a hole at the floor of the house, hole at the ceiling of the house, and how does that change the impact if the holes are in the middle of the house and not at the top and bottom?
And
Yeah.
and before you get into it, I just wanted to say you've got a great video on that.
Yep.
And that's what blew my mind to that. And I started focusing on certain areas
The
because
one,
of you,
the
because
one
of
from
you.
my house during COVID, that one.
It was you
in
were
May?
talking about C-Stack,
Yeah.
and you were
I think
talking
it's that one.
about.
Yeah.
I didn't want to jump you on that, but go ahead.
No, it's the same one. I think if you look at our YouTube channel and sort them like in chronological order, I'm pretty sure it was April of 2020. So like right after COVID started. And we were
Yeah,
all-
I think so.
Yeah.
Yeah.
So talk to us about holes in relationship to natural impact of infiltrations.
Yeah.
Okay.
Huge. This is a big
So
one.
when we talked about guarded tests, we talked about blocking the leaks because by making the same pressure on each side.
Right.
So most of us have seen like C-Stack and how there's a neutral pressure plane in the house somewhere. Okay. And so at the top of the house is typically the highest, top and bottom are the highest pressures, but somewhere in the middle of the house, it goes to zero.
Let's get a quick explanation, Steve. When it goes to zero, also called the neutral pressure plane.
Yeah.
What is the neutral pressure plane?
The neutral pressure plane is where the pressure inside the house equals the pressure outside the house. What level in the house? Now, if there's no wind,
Right.
then the neutral pressure plane will be flat.
Which means there's
horizontal.
no leaks, no flow at that point.
Well,
Without wind.
let's
Without wind.
Yeah, let's clarify. When you
Sure.
say no leaks, do we mean holes or do we mean air flowing? Okay, so
There's no air flowing.
Yes, if there is a hole, even a pretty big hole at the neutral pressure plane, it won't leak because it's the same pressure inside and out.
And what we need to clarify right now is there's got to be temperature differential. Temperature differential is what drives the flow. So without
That's
temperature
true.
differential,
No.
right?
No,
Oh
No,
no.
am I wrong? I thought the whole point of
temperature differential creates a pressure. Pressure drives the flow.
Dude, I was with
No,
you on that one.
I skipped a step. But I
Temperature
thought
drives
temperature-
pressure, pressure drives flow.
Yes, and let me explain why what you said is not quite correct.
Okay.
So what when we have the neutral pressure plane, it can be 40 degrees
Oh,
outside and
wait.
70 degrees inside, but there's no pressure difference,
Yeah.
Wow.
and so there's no leakage.
You're gonna tell me if you put a lid on it, the problem goes away. Is that where you're headed?
No, I just
Oh,
I
I'm
was just
sorry.
was saying that there can be a temperature difference, but no pressure difference, and when that happens, there's no flow, there's no leakage.
Which
That's
real
wild.
quick, I'm gonna give an example, which it brought everything like full circle to me this past winter.
Okay.
Yep.
I was actually leaving for work, right? And we have a leaky garage door and we have an attached garage. And I was putting my shoes on. I noticed how leaky the cold air was coming in at the bottom. The gaskets are leaking, right? I could feel
Right.
the air, the drafts coming in. And then for whatever reason, I was standing up and I started raising my hand along the door and they just stopped.
Oh.
Everything stopped. And if I would have got out a smoke pen, you could actually see everything shift the higher up you get, right? Because
Really?
I found my neutral pressure plane at those temperatures.
At
right?
those temperatures.
Yep.
Yeah.
Yeah, same thing. My brother posted a photo on how cold it was in North Dakota,
Right.
and he showed the frost on the bottom of his front door, and it went about halfway up the door, and then there was no frost because now above that it was leaking warm air out, not leaking cold air in.
Right. This video just changed my mind on like so much stuff.
Yeah.
It blew my mind away.
Yeah. So now let's talk about where is the neutral pressure plane under no wind conditions and how does that affect the leakage? So if we just discussed that where the neutral pressure plane is, there's no airflow through the holes.
Right.
So what if the neutral pressure plane is really close to the ceiling? Or what if it's really close to the floor? Well, if it's really close to the ceiling, that tells us a couple of things. That wherever that neutral pressure plane is, there's not going to be any leakage. But also it tells us approximately half the holes are above the neutral pressure plane and half the holes, or the half of the area of the holes,
Right.
is below the neutral pressure plane. So if you're really near the ceiling and half the holes are above that,
Right.
where's all your holes?
Yeah. Yeah.
In a ceiling, right?
Yep.
But if the neutral pressure plane goes all the way to the very top of the building, then there's no leakage in the building at all, even if there's holes.
Wow.
Okay. So the neutral pressure plane can get all the way to the ceiling, but that really assumes that your house is essentially a bathtub, right? It's perfectly sealed on the bottom and there's only holes on the top. And then in that case, that's an extreme case that never actually happens.
Yeah.
But the house would not leak even if there were tons of holes in the ceiling, if there's no holes in the bottom. And that's because the air has to get in and out.
And it matters what season we're in too.
Yeah.
Right. In
Yeah.
the heating or cooling season.
Well, not if you only have holes in the lid.
If you only have holes in the lid, then it won't leak, again, assuming no wind,
Right.
because the neutral pressure plane will always be at the same level as the holes,
Right. Yeah.
which means the neutral pressure plane is zero pressure, which means there's no leakage.
So, the worst conditions you can have is the same amount of holes in the top and the bottom of the house. And then you have a straw.
Yeah.
When you have a
Oh.
straw, that's when you have
Yep.
the most impact of infiltration
Yeah.
from your leakage.
Yeah.
If the holes are stacked on one side, you're okay.
Yeah.
Which
So you got a leaky ceiling, and then you got a house that's like on a crawl space and really leaky at the floor too.
Right.
That's when you like got your perfect stack. It's holes at the bottom, holes at the top, and maximum height.
So, and one thing I wanted to mention too is, which I'm still like I played around with C-Stack, you showed us how to use that and that, but like, if you have like me, multi-story house, in the Chicagoland area, and we're talking about stack effect and or reverse stack effect, where the neutral pressure plane is, and you start playing around with air sealing, you start changing the location of the neutral pressure plane. So if you have drafts at one location of the house and you start sealing something up, you're relocating where the leakage points. You're moving where the air is
so you
leaking
can make
in.
it worse.
Well, it depends on where grandma's sitting in a rocking chair.
Right.
Right.
Dude.
Okay.
it's-
So
you can't actually make it worse. If
Okay.
you do air sealing, the total leakage always goes down.
Okay. Okay.
But some holes that used to be leaking in might now be leaking out.
Oh, okay. That's weird.
so
Dude, we went deep.
It's
Okay.
heavy. This is Jenry Garcia stuff right
Yeah,
here.
This is
so we went deep.
going
but
Miami
but
deep.
I feel like to bring this full circle, we need a simpler explanation, Steve. And what I mean is, in the simplest of terms, nobody really has to understand all of what we talked about, right?
Right.
The idea is, all goes back to Gary Nelson. We just need to put caulk and cracks.
Yeah.
Like that's Gary's term. That's what he
okay.
says.
Yeah. I mean,
And so
yeah,
really
you
what
can't
we're
make it
after
worse.
is you don't have to necessarily know how to measure a neutral pressure plane. You don't have to use C-Stack. You don't have to do all of this stuff to be a building science awesome guy doing the work in the field. You need to know how to run a blower door.
Right.
And you need to know how to put caulk and cracks and get your number down.
Yeah.
And you're awesome, right? You're awesome if you're doing
That's it.
that. And then if you want to tier up to a big building, or if you want to do multifamily, there's a process to get there, but you don't necessarily have to go there. There's stepping stones to
But
this.
watching your video, and hopefully I'm not wrong in saying this, it let me focus. Being in Florida, I focused more on the ceiling for some reason after watching the video.
Well,
It's partly because you got slab on grade houses, right?
Yes.
Mhm.
Yeah.
Okay. So yeah, at least it got me in the right direction.
Yeah.
So I focused on can lights and mostly everything that was in the ceiling, caulk foam, everything.
Yep. Plumbing penetrations.
Yeah.
Yeah. All that stuff.
Yep. Yeah. So
And if you push Gary on it and you say, Gary, should we be using ACH 50 or should we be using CFM per shell area? We can also normalize by floor area if we wanted to.
Right.
Which one is most important? And Gary's answer is, let's get caulk and cracks.
yeah,
just get leakage down.
let's seal some stuff up.
Yep.
That's true.